Okay guys, so here's the thing. We gotta think of a really good intro to really, boom, bring Matt Matters into 2018, because this is the first episode. It's based off an old school project. I just think this is gonna be a really interesting one. And we just gotta find a great way to just... Oh! Hey! Hi guys. Yeah, sorry, I'm just, talking to my, stuffed animals. I have no friends. Jumble, why are you eating snacks? Jumble, we don't have snacks in here. You can't eat on set. It's not professional. Gosh, okay. Hello everyone and welcome back to Cosmo's Universe. My name is Matt and today we have another episode of Matt Matters where I am recreating an old school presentation, one about plasma. Plasma is considered the fourth state of matter. So you've been taught about solid, liquid and gas, and you may already know that now there's a fourth one that's been added to the roster. Essentially, quote, a cloud of protons, neutrons and electrons where all the electrons have come loose from their respective molecules and atoms. What this means is that a substance of plasma acts more as a whole rather than lots of individual atoms, say like a gas. Now, obviously, plasma is more like a gas than the other states of matter. You see, it's the highest energy levels. It's what happens when you heat up a gas, but I'll come on to that in more detail in a moment. It has what scientists call collective behavior. What it means is that plasmas can flow like a liquid or contain areas that are sticking, clumping together, much like a solid. So how are plasmas created? Essentially, it's like the next level up from gas. So by putting more energy or maybe heating up a gas, you can create a plasma, but it's not just a physical process, it's also a chemical one. There's this thing called ionization, which essentially involves gaining or losing electrons in, the respective atoms that are turning from gas to a plasma. Ionization is the process of an atom or a molecule gaining or losing an electron and therefore getting a positive or negative charge as a result. This way it forms an ion, which for those of you who don't know is basically an atom with a charge, so there's an imbalance in the number of protons and electrons it has. So electrons and a negative charge, protons are the positive one. It's kind of obvious when you really think about it. And all this is fascinating, honestly, because the idea of plasmas is this very high energy, very hot kind of material that isn't quite like any of the other three states of matter is interesting. But what can it actually be used for? What does this information help us? How can we exploit it? So examples of plasma include fluorescent light bulbs, neon signs, plasma TVs, plasma globes, the auroras, and even the stars themselves, which is really the most obvious. With some forms of technology, the way they work is that a gas, such as neon, is exposed to an electrical charge that separates the electrons from their respective atoms because they have a much higher energy level. Some electrons drop back into their previous energy levels and they emit photons, light particles. With TVs, a gas, again, neon, maybe argon or xenon, these kind of noble gases and less reactive ones, are injected into a sealed gap between two glass panels, and the same process that I just explained causes it to glow. It releases those photons from the particles moving between energy levels. There are also phosphors, of course, with blue, green and red colours, and this way, by exciting different phosphors, you can get pretty much every colour. You gotta remember, although these plasmas are extremely hot, they usually have to be contained inside ceramics like glass because they don't conduct heat very well. There are also examples in nature though. Like I said, the auroras. Solar wind is a stream of charged particles that follow Earth's magnetic lines and collide with particles in our atmosphere, such as nitrogen and oxygen. The light you see being given off is due to the same process as explained with the other two. And I tell you what, that's handy dandy, but there's a bit more to it. Because also, when you're looking at scientific development, you can look at the past, the present, but you also got to look at the future. And there are some truly innovative ideas that are, kind of coming to shape now, as well as the future. In the future, we may use plasma for burning rubbish. And I know how bad that sounds, just hear me out. If plasmas were burned to a high enough temperature at such an intensity, then gasification would completely destroy the structure of any rubbish. A design does exist, because if you then had a chamber which cooled it down correctly without releasing any carbon dioxide into the atmosphere, waste could be converted into a flammable syngas fuel or an inert slag to be used as building material. This way, even though it couldn't destroy nuclear waste or heavy metals, going over the landfills with a plasma torch could literally solve half the world's problems with no carbon footprint. But, again, it needs a bit of development. It's too good to be true. Another futuristic one is surgery and medicine. Imagine a plasma skipper, like a tiny lightsaber, but it's like a laser torch. It can cut through anything that isn't a plasma easily. The heat of the plasma would also cauterize tissues so that the wound won't bleed, and that minimizes collateral damage in surgeries with, traditional metal scalpel. Can't talk. Plus, it would be antiseptic because the heat would actually be enough to kill microbes that were infecting, say, one part of the body. And the reason that I can say all this in such detail is because, of course, they actually already exist. Essentially, it works by blasting pressurized gas at thousands of meters per second and then electrically ionizing it. That's amazing, but that's a thing, and that is pretty much everything. Plasma is something very different to the other states of matter. Fundamentally, it's not just a physical change, but a chemical change. But this matter could be an asset to science and technology even more than it is already. Plasma is what makes the stars. I did mention this earlier, but I didn't explain it. It is crucial in forming the universe, and there are many ways we have already adapted this technology to suit what needs that humanity has. So it looks like we might be able to take it that next step as well. As always, yeah. Precisely, guys, bibliography, you already know it. It's still rolling. Why haven't we cut yet? So guys, that's all for today. If you did enjoy this video, please remember to leave a like, subscribe, and hit the bell to be notified of all the new content coming to Cosmo's universe. Share this with your friends if you're already subscribed, and comment any ideas for future videos or just stuff below. As always, guys, my name is Matt, and until the next time, bye-bye.